So now that we have learned about solution concentrations, hello, shh, I'm starting now. Now that we've learned about solution concentrations, we can use molarity in stoichiometry calculations. So the molarity relates moles of solute to liters of solution. And so we can use this on the beginning of our stoichiometry calculation or on the end instead of the mass. So our little mantra for stoichiometry was grams to moles to moles to grams. And that is still the basic path, but we can switch it up. So instead of starting with a mass of reactant A, perhaps, we could start with a volume of solution containing A if we know the concentration. Because with molarity, we can change volume into moles. And we can do that at the end as well. Or we may just do the beginning or just do the end. There's all sorts of variations. So let's look at a problem. What volume in milliliters of a 0.150 molar nitric acid solution will completely react with 35.7 milliliters of a 0.108 molar sodium carbonate solution according to the following balanced chemical equation? And we're given the balanced chemical equation. So this is stoichiometry. We've got two different substances. We've got nitric acid and we've got sodium carbonate. And we are given information about one and asked a question about the other. But instead of going grams to moles to grams, we're going to do volume. And so our path here is going to be, well, let me back up a little bit. Let's first write down what information we have. So we've got 0.150 molar nitric acid. So I'm going to write that under nitric acid, 0.150. And instead of capital M, I'm going to write moles over liters to remind myself that that is a fraction. And then we have 35.7 milliliters of the sodium carbonate. So I'm going to write that over here, 35.7 milliliters. And I'm also given a mass here, not a mass, a molarity. Boy, you have 4 days off and your brain just turns to mush. Okay? And then what's the question? What volume in milliliters of nitric acid? So here's our question, and the unit we're asked to provide is milliliters. Stoichiometry problems can always be done using a dimensional analysis approach. And so we're going to look at what we're starting with here. This is the thing we have the most information about. This is the thing we have the question about. So this is going to be at the end, and this has to be at the beginning. And then we're curious, well, do I start with the milliliters or do I start with the concentration? The units tell us that we should use moles per liter as a conversion factor, and we should use milliliters as our beginning. And so our path is going to be milliliters of sodium carbonate. And then we're going to go to moles of sodium carbonate. And then we're going to go to what? Moles of the thing we're asked about, the HNO3. And then we want to go to milliliters of HNO3. Any questions? Well, let's start writing this out. So I've got 35.7. This is going to be similar to that kilogram to kilogram problem we did, where we've got this prefix milli here that is not going to cancel out right away. So I'm going to put that milli in orange just to kind of draw attention to it, I'm going to go liters to moles to liters with my units, and this milli is just going to hang out and show up again at the end. Everybody okay with that? So I'm starting with volume of sodium carbonate, and then I'm going to convert to moles of sodium carbonate. And then to moles of nitric acid. And then to liters of nitric acid. And I'm going to stick my units in. Now let's look at what happens. This is molarity, moles per liter. That's this number right here. The reason I wrote the milli in orange is because liters down here is not going to cancel the milliliters. I could convert from milliliters to liters, and if that makes more sense to you, go right ahead and do that. What you'll find, though, is that you'll have to convert from liters to milliliters at the end, and they'll end up canceling each other out. So I'm going to just set the milli aside, and liters of sodium carbonate cancel liters of sodium carbonate. Moles of sodium carbonate cancel moles of sodium carbonate. Moles of nitric acid cancel moles of nitric acid. And the unit I'm left with is liters and the prefix milli. So I am going to end up with milliliters of nitric acid. So we've got all our units in place. Question?
Are you going to want us to show it our work like this way, or can we do it the other way?
Which other way?
Like cross multiply, or multiply them together and divide by the other one?
You can't use the dilution equation for stoichiometry. Okay, it's a common mistake. So M1V1 equals M2V2 is for diluting a solution, not when you have one substance converting to another in a chemical reaction. What's very insidious about it is that if your mole ratios are the same, the dilution equation will give you the correct answer. But most of the time, your mole ratios are not the same, not equal to 1. And so then you end up with the wrong answer and you don't know why. So thank you for mentioning that. So yes, I want you to show it this way. So in the middle, we have our mole ratio. Moles of nitric acid to moles of sodium carbonate. And this comes from the balanced chemical equation. We've got 1 mole of sodium carbonate for every 2 moles of nitric acid. What's nice about solution stoichiometry is you don't have to calculate molar masses. They give you the concentrations. And so for sodium carbonate, we know that the concentration is 0.108 moles per liter. And of course, I didn't leave enough room. I'll write it at an angle here, 108 moles per liter. If you want a number on the bottom, it would be 1. And then we go over here, and we've got 0.150 moles per liter. Moles is on the bottom, and so that's where the number has to go. 0.150. If we want a number on the top, it's going to be 1. Any questions? Interesting. So now I get out my calculator. 35.7 times 0.108 times 2 divided by 0.150 equals. How many significant figures should the answer have? 3. So this will be 51.4 milliliters. Any questions? So this is the same idea. This is stoichiometry, but instead of grams to moles to moles to grams, this time we did volume to moles to moles to volume.
Which is in essence simpler because it gives you information. Right?
It is simpler in practice because you don't have to go calculate molar masses. They have to give you the concentration if you're doing the solution. Or they could possibly tell you that you're going to end up with a certain volume and ask you what the concentration is. And that's a little variation as well. But if you get comfortable working with units and doing dimensional analysis, then solving these problems is not difficult at all. If you're still struggling with dimensional analysis, please come talk to me. So any questions?